Now let's jump to another concept which is also very key to understand how roaming works. Suppose that your client, your laptop, is associated to an access point connecting to a controller. And whether that controller is an MC or only an MA doesn't matter. What matters is that your traffic is going to go through that green line to the controller, and you will have to define 2 points in the network, the POA and the POP. The POA is what we call the point of attachment. This is the controller to which the access point that your client is using is connected. That's your MA basically. So of course, your point of attachment here is the first controller on the way because that's where your access point attaches. But there is another concept, which is the POP, which is the point of presence. The point of presence is where the rest of the world sees you, wireless client. Of course, the rest of the world is wired, so it doesn't see your wireless MAC address in the air, but because you go through that controller and the controller is going to forward your traffic up to the wire, the rest of the world will see you coming out of that controller. So the POP is the point of presence for that device MAC address, the client MAC address, from the rest of the network standpoint. And that is, of course, typically on the way out of your controller. This is where a MAC address is going to be seen. Why does that matter? Well, because if you roam from one access point to the other, a few things are going to happen. One of them, of course, is that your point of attachment is going to change because the controller you're going to use is going to be different. So your POA is going to follow you just like it follows whatever controller the access point you're connecting to is connecting now. What about your point of presence? Well, that's the thing. What we try to do is keep it the way it is. And the reason why is because your SSID might be WLAN A and you may be in VLAN 5. If we move your point of presence, there are a few things that may be damaging to your communication. One is that the association between the SSID and the VLAN might be different on the right, which means that you would be in a different subnet. So we may have a problem here where your IP address is suddenly not right anymore and you may have to re-authenticate. We don't want that. So we're going to distinguish a few cases. One case is when the mapping between the SSID and the VLAN is the same on the controller you come from and on the controller you come to. So in that example, you have WLAN A and it's associated to VLAN 5 on the left side and it's the same mapping on the right side. So in that case, we can move you entirely from one controller to the other because there is no interruption in your traffic because you're in the same VLAN on the right side. So in that case, we call this a layer 2 roam. Layer 2 because there is no IP issue here. You are in the same subnet in the same VLAN on the left and on the right. So layer 2 roam, keep that in mind, is when you move from one IP to the other, connecting to two controllers, of course, where the SSID to VLAN association, VLAN to SSID mapping is the same on both sides. That's a layer 2 roam. Okay, in that case, we can move you safely. So we're going to take your client context, everything we know about you, QoS, security, everything, and we're going to send that from one controller to the other. And then the controller on the right is going to keep your client context and the controller on the left is simply going to remove it because it doesn't need it anymore. And that makes that your point of presence is going to move from the controller on the left to the controller on the right while the controller on the left forgets about you. Your POP moves and your POA moves as well. Now, that's a case where the mapping is the same. That kind of roaming is called layer 2 roam, remember? There is another terminology we use often, which is local to local. Just because you were local on the first controller, and because we move you to the other controller, you're now local on that new controller as well, so it's a local to local move. So layer 2 roam, local to local, those are the same concept, two different terms for the same event that you see here. Now let's take another case. Your SSID mapping to VLAN is A to VLAN 5 on the left, but on the right this time, of course the SSID is the same, otherwise there is no roaming, right? You just disconnect and reconnect. But if you roam, keeping the same SSID, suppose that this time the VLAN association is different. It's VLAN 10 on the right. So now we have a problem, because if we do that, that's a layer 3 roam, meaning that if we move you entirely from the left to the right, you are going to have to be in VLAN 10. And that's another subnet. So what about your IP address? You're going to drop here. You have to reassociate and get a new IP address. That's very damaging. So we don't want to do that. So what we're going to do in that case is that we're going to take the client context on the left. We are still going to send it to the right so that the controller on the right knows about you. And of course, your point of attachment still moves, right? Because it follows mechanically whatever access point you're connecting to. But what we'll try to do is to keep that client context on both sides. And this will make that we'll try to encapsulate traffic that gets from you on the right side and forward it to the left side, so you stay in the same VLAN. And this is critical because VLAN 5 maybe doesn't even exist on the right side. So we're going to maintain your POP in that case. So in the layer 2 roam or local to local roam, your POP follows you as you move. But if the VLAN to SSID mapping is different between the first controller and the second one, this is a layer 3 roam, and we try to keep your POP where it was. We don't move it. Your POA, of course, moved along with you. That layer 3 roam is going to create another concept that we call anchor and foreign. The new controller to where you roamed to is called the foreign controller. And the controller to where we try to keep you from a POP standpoint is your anchor, because this is where your VLAN exists, and this is where the rest of the network knows about you. Regardless of what controller you move to, from foreign to foreign, we're going to keep sending your traffic back to the anchor as long as the mapping is different from what it was on the anchor between the SSID and the VLAN. That layer 3 roaming is also called local to foreign roaming, just because you're not staying on the same controller anymore and we still tunnel you back to the anchor. And if you don't stay on that controller on the right and you keep on moving to some other controllers where, again, SSID A is still not associated to VLAN 5, we'll keep on sending you back to that one anchor as long as you move. And that movement from that first foreign to another one is going to be called foreign to foreign, and we continue moving you until, we find a place where the VLAN to SSID association is the same. When that happens, we can finally bring your context back to that controller where SSID-A is also VLAN 5, and we'll call that roaming foreign to local, because that's finally when we'll be able to move your POP back as if it was layer 2 roam, because at last we found a place where SSID-A to VLAN mapping was the same as on your anchor. So you have to understand those vocabularies, right? Local to foreign to foreign as you continue roaming, and foreign to local when you get back to a controller where the mapping is the same as where you started from. All this is a layer 3 roam. There is a last concept that you will hear around anchoring, and that concept is called auto-anchoring. What that is typically you have this DMZ concept where there is a controller for your guest traffic, for example. And in the auto-anchor logic, what we want to do is to always send traffic for a specific SSID to one controller. In the guest example, you'll say, I don't know what access points my clients are going to be connecting through, but whatever they are in my building, I want their traffic to be always sent to the controller in the DMZ, so they are behind my firewall and they are always sitting to the internet and not going back into my network. So that's auto-anchoring is a feature by which you send always to the same place, regardless of roaming and association, etc. So that's a different configuration, but it's the same term, anchor, because you want to hook the POP and let it be at one single location. In that case, we do not care about what controller you are associating through. We will always configure that controller to send traffic for that SSID to a specific controller IP address, and we'll configure that in the upcoming module as well. The concepts are still the same. The controller in the DMZ is still your anchor because that's where your POP stays, and the other controllers are still foreigns because these are the ones through which you connect and through which traffic is being sent back to the anchor.